this video, we're going to be looking at rewriting an exponential function. So number 1 states to rewrite the function in the form y is equal to a times 1 plus r to the t, or y is equal to a times 1 minus r raised to the t. Then state the growth or decay rate. So part A, I have y is equal to a times 4 raised to the t to the over 6 power. So I want to rewrite this so it's 1 plus r or 1 minus r, and I just want it raised to the t power. Right now it's raised to the t divided by 6. However, we learned in our previous unit the power of a power property. So that means I can actually rewrite this to be a times 4 to the 1 over 6 all raised to the t. And the reason why I can do that is because we know from the power of power property that when we raise an exponent to a power, we multiply those exponents. And 1/6 times t, I get that t over 6. So I'm just reversing that power. And now I'm going to evaluate that power. So I can go over to Desmos here, and I'm going to hit 4, this a to the b button, and then do 1 divided by 6. And I get this big number. And so I'm just going to do the 4 decimal places. So I have a times 1.2599 raised to the t power. And now for my last step, I just need to rewrite this to be in the form 1 plus r or 1 minus r. Well, since this is bigger than 1, it's going to be 1 plus r. And so this is going to be that y is equal to a times 1 plus 0.2599 raised to the t. And then the second part of the question says to state the growth or decay rate. Since this one's 1 plus, this is going to be growth rate. So the growth rate here is 0.2599 or 25.99%. Okay, let's look at one more. Here I have y is equal to 0.25 raised to the t over 9. Again, I'm going to use that power of a power property to rewrite this to say 0.25 raised to the 1/9, all raised to the t. So going back over to Desmos, I can evaluate that power, and so I have 0.25, I'll change that to 1/9, and I get this number, so I have 0.8572 raised to the t. And now I need to write this as 1 plus or 1 minus. Since this is less than 1, it's going to be 1 minus, so I know that r is just going to equal to 1 minus 0.8572. And if I do that, 1 minus 0.8572, I get 0.1428. So that means that y is approximately 1 minus 0.1428 raised to the t power. So since this one's minus, this is going to be a decay rate. So this is going to be a decay rate of 0.1428 or 14.28%. Okay, now let's look at a word problem. So this one says the amount y in grams of the radioactive isotope chromium-51 remaining after t days is y is equal to a times 0.5 t to over 28 power, where a is the initial amount in grams. What percent of the chromium-51 decays each day? So for this one, we know that the rate is going to come from that 1 plus or 1 minus r, and that r is our rate. However, this isn't written in that form. So we're going to have to do the same steps that we did in number 1 to rewrite it in that form so that we can know what that decay rate is. So I have y is equal to a times 0.5 t over 28. I want this to be raised to the t, so I can rewrite this to be a times 0.5, so 1 over 28, all raised to the t. And then I need to evaluate that power. So I come up here, 0.5, 28, and I get approximately 0.9755 raised to the t. But now I need to rewrite this in the form of y equals a times 1 minus r to the t. So I need to figure out what that r is. And so I know that the r is just going to be equal to 1 minus 0.9755, which when I subtract that, I get 0.0245. And so this becomes that y is approximately a times 1 minus 0.0245 raised to the t. And so that means that the daily decay rate is about 0.0245 or 2.45%.